All right, hello everybody. In this video, we're going to talk about Fischer projections. So Fischer projections are another way of representing molecules that have chirality centers. And we have an example of a Fischer projection down here. And if you notice, in the Fischer projection, there aren't any wedges and dashes. And so it's sort of a quick way to represent chirality centers. And the convention is that the vertical lines actually represent dashes, and the horizontal lines represent wedges. And so this is how we go from a two-dimensional drawing to imagining the three-dimensional structure. One of the most useful uses of Fischer projections is for representing molecules that have multiple chirality centers. And most often, Fischer projections are used to represent sugars, which we'll get to in the second semester of organic chemistry. But when we draw these Fischer projections, wherever we have the crosses, the center of that cross is a chirality center. So I can immediately look at this molecule and see that it has two chirality centers. This one has 3, and this one has 4. Another really useful aspect of Fischer projections is it's really quickly to determine whether two compounds are enantiomers or diastereomers. And if I start with a given compound, I'm looking at the groups that are going to the left and the right. If I have a second compound where the left and the right have all been switched, right? So in this case, bromine's on the right, hydrogen's on the left, bromine's on the right, hydrogen's on the left. If I swap both of them, then I know that they're enantiomers. And so, if everything that is on the right is now on the left, then they're enantiomers. If that's not the case, right? So in this case, right, this bromine switched, but this one stayed the same. So they're not the same compound, and they're not enantiomers, so they must be diastereomers. The last thing we're going to do, and we're look at a couple examples, is given a Fischer projection, we want to be able to assign R and S configurations. Right, so normally when we're assigning R and S, we're imagining something that looks like this, and so we want to go from a Fischer projection to something that has wedges and dashes. And the easiest way to do that is to take any one vertical line and rewrite that as a dash, and then take any one horizontal line, it doesn't matter which one, and rewrite that as a wedge, and then we can assign the R and S configurations like we would normally. So, right, I'm just going to randomly pick this one, convert that into a dash. I'll convert that one into a wedge, and now I'll assign the R and S configurations like I would normally. So I think the OH gets priority 1. I've got a hydrogen and 2 carbons, so the carbon with 2 bonds to oxygen gets priority 2, 3, and 4. And so when I look at my 1, 2, and 3, right, they're going clockwise. But because the hydrogen is not back, I'd have to switch these two. So right now it looks clockwise because I got to swap them because the hydrogen is not back. It's actually going to be S. All right, here's another example. So I'll just pick, right, make that the dash. We'll make that the wedge. And then I think my priorities would be 1, 2, 3. And again, right, these are going clockwise, but because the hydrogen's not back, it's going to be the opposite. So it's not R, but it's going to be S again. Okay, here's an example where we have multiple chirality centers, but we're just going to do this the same way we did for the one chiral center. So I move this, give us a little bit more room. So remember the 4 chiral centers are the ones on the crosses. So if we do this one first, right, I'll pick one vertical, make it a dash, one horizontal, make it a wedge. I need to assign my priorities. So I think the OH gets 1, the carbon with 2 bonds to oxygen gets 2, the carbon with 1 bond to oxygen gets 3. Of course, the hydrogen is 4. And right when I go 1, 2, 3, I'm going counterclockwise. Right, because the hydrogen is not in the back, it's going to be the opposite of this, and so it's not S, but that chiral center is going to be R. me go to the next slide where I've got a clean template. All right, so same molecule. I just wanted to erase what I'd done before, so now we're going to assign this chiral center. So again, we'll give our priorities. So we've got 1. Now assigning the what should be 2 is a little bit tricky, right? Because I've got carbon, carbon, right? They both have an OH and H and a carbon. So I need to go 1 more out. Now I've got a double bond to an oxygen. Now I've got not a double bond to oxygen, just an OH. And so I think this will have the higher priority. So we've got 1, 2, 3. And of course the hydrogen is 4. Right, and so now when I go 1, 2, 3, I'm going clockwise, but again, right, I didn't draw in. Right, we'll make 1 dash, 1 wedge. I should say, right, if I had made other choices for the dash and the wedge, I'm always going to still get the same answer. I'm always pretty consistent, and I always do the dash up and the wedge to the left, but it doesn't matter. If I'd done the dash down and the wedge to the right, or the dash down and the wedge to the left, I'll still get the same answer regardless of which ones I pick. Okay, so 1, 2, 3, right, these are going clockwise, but of course, because the hydrogen is not in the back, it's going to be the opposite, so it's not clockwise, so it's in fact going to be not R, but this one's going to be S. All right, we'll go to a fresh slide again. And same thing, now we're going to assign the third chirality center. So let's put in my dash and the wedge. All right, we'll assign our priorities. So again, the OH is going to be 1. Again, these 2 carbons are the tricky ones. I've got a carbon with an OH and an H, carbon with an OH and an H and a carbon. Right, I go again. And I've got the OH, H, and C. Right now I've got 2 hydrogens. So again, I think the higher priority is going to be up. So it's 1, 2, 3. And the hydrogen, of course, is 4. And again, I'm going clockwise, but with the hydrogen not in the back, it's going to be the opposite. So that's in fact going to be S. All right, and we'll do the last one on the next slide. All right, we'll draw in dash, wedge, oxygen gets 1. Now, again, we've got to decide between those 2 carbons. Again, I've got 2 hydrogens and an oxygen. I've got a hydrogen, oxygen, and a carbon. So again, the higher priority is going to be up. 3, hydrogen is again 4. Right, and again, we're going counterclockwise, but again, the hydrogen is not in the back, so it's the opposite. So this one is R. And at least when we're doing sugars, so this may be helpful, particularly when you get into the second semester, but you know, when I've got the aldehyde at the top, and alcohol at the bottom, and I've got all H's and OH's in the middles, this is what I'm looking for a carbohydrate. It could also be that the double bond O is here. In fructose, we'll see that. But a quick way to be able to tell these, if you noticed, whenever the OH was on the right and the H was on the left, if you go back and look, we assign that as R. When the OH is on the left, we assign that as S. When the OH is on the left, we assign that as S. So I'd be careful. You know, I think this only really works for carbohydrates. But if you know you've got a carbohydrate, you don't have to go through this whole process. You can just quickly look and say, oh, the OH is on the right, the H is on the left. Right, I tend to just focus on the OHs. Right, OH to the right, R. OH to the left, S. But if it's not a carbohydrate, then I think you have to go through the process like we did here.